So another example of graphing inequalities is something that looks like this. We've got y is less than or equal to negative 2x plus 4, and x is greater than negative 3. So I know a couple things already. I know this is in slope-intercept form, and that I'm going to have to shade one side or the other of a line that should be solid. The line should be solid because I have or equal to. Here, I have x is a number, which seems a little odd. But when x is a number, it ends up just being a vertical line wherever this number is. Just like when y equals a number, it's a horizontal line. When x equals a number, it's going to be a vertical line. So because this is actually really quite easy to graph, I'm going to take my black marker and I'm going to come over to where x equals negative 3 on my graph, and I'm going to put a point right here. And then I'm just going to draw a vertical line right through. And I know it should be a dashed line because it is just greater than. And it does not include the set of points that is on the line. And just because it's good practice, I'm always going to label this x greater than negative 3. And I even like to label my point. This is negative 3 for x and 0 for y. And anywhere on this line, x would still be negative 3. Okay? Now, looking at the second, well, before we look at the second, we need to shade one side. Where are my x values greater than negative 3? Well, if I pick a point out here, and this point is 4, negative 1, 4, this number right here, is 4 is greater than negative 3, so I know that I'm going to shade this side right here. Now I'm done with this inequality. I want to go to my first inequality. My first inequality is in slope-intercept form, and I know my intercept is 0, 4. So I go 1, 2, 3, 4, put my dot right there. Label my point. And I know my slope is negative 2, which means I'm going to go down 2 and to the right 1. I see that I have the or equals sign, which we talked about before. We're going to draw a solid line. And I want to make sure I draw my line far enough that it goes through my other line that I've drawn. Label your line with your equation, y less than or equal to negative 2x plus 4. Label your points, 1, 2, and 0, 4. Now we need to look at what side are we going to label. Well, when I have test 0, 0, we're going to say 0 is less than or equal to negative 2 times 0 plus 4. 0 is less than or equal to, well, this multiplication will always be 0. 0 is less than or equal to 4. That is true. We're going to put a check mark there. And I'm going to shade because 0, 0 is on this side of the line, and it's true. I'm going to shade this way. And again, we have 4 regions of the graph. We have the region where neither are true, which is this region up here that just is going to get bigger and bigger up there. We've got the region where just the black equation, which is x is greater than -3, is true. That's out here. We've got the region where the red is true, which is from here over and this little part down. And then we've got our feasibility region. That feasibility region is where both the red and black are. Just so we remember what it's called, let's write it in. We've got the feasibility region, and I'm going to get rid of all my highlighting outside so it makes it nice and clear what my feasibility region really is. Get rid of this shading over here. And if you are doing your homework in pen, which I know a lot of you do, make sure you just darken this region because sometimes you're just not working with something that can be erased. That's why pencil is sometimes the best medium to use. So you can even just, even with this, I can come and I can darken all of this area in here because at any point in there makes it true. You can use red and black because both are true in here. This is my feasibility region. This would be the solution to this system of inequalities. And that solution has an infinite number of points in this area. And that's how we graph a system of inequalities when maybe our forms are a little bit different.